Hello everybody, this is the second lab in MATLAB program. So last lab we say something about introductory and what is the basics of MATLAB, the variable, how to write something on MATLAB, how to use it, how to open it, and what is the main window that we see when we open the MATLAB. So today we will go further with something in the basics already. So we cover all of this next. Yeah. So about the trigonometric function, the trigonometric function is the cosine and sine, the famous cosine and sine. So cosine and sine also it have a function, the reserved function for it in the MATLAB. So you can just write the cosine of 30 or sine of 5 or something, and you will get the number, the value of the function that you apply, like in the normal calculator or the scientific calculator that you already use in calculus or mathematics class. Okay, now you have here, there is two type of trigonometric function. This is the radian function, and there is the degree function. So here, as you see here, this is the inverse type of signal. Say cosine to the minus 1, cot cosinus and sinus and sine, tan, cosec, cosine, so the tan and sine. So this is all of them. If you write here 15, 16, 19, so the value here is in radian. So this is cosine using radian. However, there is something. So the radian means that it's 2 by the value of degree, 2 by of the degree. So if the degree from 0 to 36, yes, 360. So 300 from 0 to 360. This is in degree. This is the full degree of a circle. Then if you pick one of these degree and put it here, it's not working actually correct, because this is radian. So the same degree multiplied by 2 pi. However, if you want to just calculate the function for the degree itself, then you just add d after the name of the function. You just add d here, that this is for degree, d, all of them the same, but difference is d. Okay, so this is the main difference between this and that. Now it's a hyperbolic function. This is another type of function that we have already in mathematics. I don't know if you take it before in calculus or algebra or not, but this is the function that we use for hyperbolic function. Cosine, cotangent, cosec, and cosine and whatever, and the inverse of them. This is the inverse of the function, so you don't have to write the inverse function yourself. You just use a before the function or the function itself. Okay, now there is the mathematical function factorial. So if you know or you remember from the mathematics function that you see in the calculus, there is factorial. One, if it is a factorial of 3, it is 1 multiplied by 2 multiplied by 3. This is giving you the factorial. A factorial of 5, 1 multiplied by 2 multiplied by 3 multiplied by 4 multiplied by 5. So this is what is the meaning by the factorial. This is the description in mathematics, but how I get it in MATLAB, then I will get it under the item, and I write factorial. But the first, remember, I think there is all of these slides is using first letter is higher, but all of the MATLAB writing is lowercase factorial. So if I go to MATLAB and write CLC, so if factorial of 3, for example, it is 6. 2 1 1 multiplied by 2 multiplied by 3, it is 6. So like this, all of them. Okay, cosine of 30, it gives me a value, but if it is cosine d of 30, so this is the difference between both of them. Okay, now returning back to our slides, this is a command file, and the file command that we work with, the file inside the system. You can see it later. So to go to the important function, because there is hundreds of function in MATLAB. Yes, I don't know why it's every time it's going from the beginning. Yeah, so here, as you see, this is exponential function the natural number. So the exponential function gives you the value of e to the power something, exponential function exp. So I express the exponential function by exp, but the normal logarithmic, the len, if you know the len, so this guy giving log. So there is three type of log: log to the base 10, log to the base 2, log to the base e, the len function. So there is brackets here, and you write the number, you get this function. In the mathematics, you get the directly. The square root, this squared sqrt, this is a square root of something, the nth root of something. So then you have the value of the number and the root. What is the to the root, the power of the root? Okay, then this is the power of 2 to the power something, which is useful in some cases, but usually we use this description. Exponential minus 1 log to I think this is important, the first 2 or 3. Yeah, now to go to the matrices. Matrices is something that we express the working with numbers, not one number. So all of what we have before is working with one number, or yeah, in the new version we can apply to matrix or vector, but in matrices or vectors or array, we can work with a data. Now we can work with something that we can express it in hundreds of numbers or something like this. So this is the expression of the many cases in the phenomena in the real case. So what is how we can write a vector in MATLAB? We can write a vector using this parenthesis: x equal to parenthesis and 1 space 2 space and 3 space 4 space. So the spaces between both of them is giving you the column. Then you will have a column vector, column wise vector. If you put a comma, it's the same, but I think it's in the new version there is no comma. If you write a semicolon, then you will have a row wise vector like this. So the answer is like this, which is the same as if you take if you put this value, the quotation. So as we see here, this is how I implement a vector. This is the easy way of implementing. I enter every element of the vector. Another thing is this vector position is the first one, second, third. I don't know what is the background of your computer language, but here as you see that there is in Python, I think, and C++, they begin from 0. Here in MATLAB we begin from 1 2 3 4. This is the position, not the value. The position of the first element is 1, not 0. Okay, because this is important. Another type of generating or implementing the vector is to implementing the gradient line space like this, from 1 and column 10, it will give you 1 2 3 4 4 until 10 from, or you have a step in before, then it will give you, the first one is 1, 1 plus 2 is 3, then the second one plus 2 is 5, plus 2 plus 2 until it gives you the highest number. If it's higher, then I will stop. If it's lower, I will have a value. So at 9 it's okay, but at 11 it's not okay, so because the highest value that possible is 10. Okay, and you can go reverse, that if you put -1. Okay, or you can go decimal, it's with having some floating number in between. Okay, now if I want to address a value by its position, of course, if I put a and this parenthesis, I will see the position at element 3. What is the value at element 3? I see here that this is 6, so if I click enter, it will give me 6. If I want something, a space or a field, not just one value, so this is will give me from 3 to 5. What is the values here? Or from 2 to the end, I write the end to the end of the array that I have, or with a step that I have in between from. But be careful that if you write a number here from the beginning, for the ending value, supposed to be in within the limits of the array b. So of course this array is not 10 elements, it is 6 elements. So if I write here 10, it will give me an error, because I want to address, or I want to get a value of an element that is not exist in my array, so there will be a problem. Yes, so this is a type, yeah, size of a. This is a too important function. If we go to the MATLAB, if we here write a or x equal, I will use this parenthesis or 1 to the 10, and if I write semicolon, it will not showing me anything. If I write without semicolon, it will show up all of them. Then I want to address x of 3, it will give me the third one. If I want to see the size of x, it is 1 and 10. What is the size? The size is giving me the number of row and number of column. This is the number of row, it's 1 because it's one row. The row is above each other, but the column it's behind each other, vertical. So how many column? It is this column. Okay, so what is the difference between length? Length is like this, I write it, I give me the value. So length usually goes column wise, unless I specify something else. Okay, so this is how it's working. So this is the difference. Let's give me one value, but size is give me two value. Okay, now if I return back, I see that there is some additional working on value for adding value. For example, here if I want to, for example, x 10 11 and I put value, another value 12, for example, it will give me here, as you see, give me x, and I put the element number 12 as a new number 11 as a new value as 12. For example, if I want to remove this, I will put something like this. So see, I just remove it. I can change also. I can change number 1 to 0. So I change it. This is how I change a specific element, not just all of them. I already generate the function. Also, there is another type of generating the function, which is like zeros, 1 and 5, but let's name it by 1. Yeah, this is one of the something that I forget to explain it to you. The name of the variable should begin with a letter, not with a number, not with a specific character in the keyboard like slash or comma or underscore or something. It's supposed to be and have to begin with a letter, a whatever it's a letter. And MATLAB also differentiate between uppercase letter and lowercase letter, so it is sensitive for this something. And also it's but it is not sensitive for the white space. For example, if I make here a white space like this, it's not sensitive for it. It gives me the same idea. But in the name of the variable should be all connected. No, there is no white space. See, there is error here. It gives me some error. Okay, so this is not okay, this is okay. Also there is the ones. So this is another type that of vectoring or giving me an array or a matrix. It gives me the ability to create a matrix directly with a common number or common value that I can use directly without writing 1111. Or for example, if you have 100 vector white, so this you don't have to write all of them, you just write an expression or a function that just give you the right or and correct answer. Okay, I think there is yeah, the vector statistics. Then there is something called summation. For example, summation over x, it gives me a summation over all of them. Minimum, what is the minimum of x? The 0. The maximum of x, what is the maximum value in our vector or matrices? What is else? Mean. Well, mean, what is the mean value of x? It's sum all of them and multiply by the number of all of the values. Then it's 5.4 because we have 0 and 11, I think. Yeah, x, yeah, because we don't have 1, it's 0, so this is the difference. So if I go up, yeah, and 1, and then mean, yes, this is much better. Okay, now if I return back, yeah, if there is any cell, yeah, max, minimum, this is I think the standard deviation and variable mode. So this is like as I said before, there is 100 and of function that's expressing the function that you use in calculus, algebra, mathematics, and you learn it before the function for it. So this is a reserved function for in MATLAB. You don't have to learn it by yourself. So as I said before, you can use help on the function. You just write this is the quotation mark. For example, I don't know what is the function angle, so I just click help me, so it's helping you. I can change, yeah. So angle, phase angle, so it's returning the phase angle in radian of the matrix complex element, matrix or a complex element, so for x, and give me a reference in other function, and give me see also the absolute value or unwrap, whatever unwrap. Also we can use this here. As you see, I am coming up from here to here. Yeah, top and the top right side of the MATLAB, there is search documentation. I can just also write, for example, minimum. I don't know what is the minimum. It gives me a list of function. I just enter. It gives me a new window, which supposed to, yeah, working. It gives me something information about whatever the minimum. I think the first one is sufficient to give me some information. If you click and you roll in the mouse, you can enlarge, close. Yeah, see the function, what is this minimum element of an array, and the different syntaxes of the minimum, because you can specify the all the array, some dimension, specific dimension of the array, and other things that you can learn here. Some examples, description, here you can see that there is some examples that you can apply and different example with different value with different conditions. So here this is how the minimum work on if you want the minimum value of each row or each column. So this documentation, as I mentioned before, it is يعني very effective in informative, and you can learn a lot of things and examples and function here from just an offline documentation that come with the installation of your MATLAB. Also, you can use, as I said before, you can use Google and the internet to search about. Just write in the Google MATLAB space the function or the error that you face or whatever you have. Just write the first, just write the MATLAB. So when you the Google search, you will search, for example, for everything that's related to MATLAB, because this function may be inside other computer programming or other things. So you don't have to go around with the function. Usually the first or two things are coming up from online documentation from MathWorks, the company that owned MATLAB. Okay, so returning back to our line space, I think we see line space giving you a log space, giving you a different way of implementing and generating our array or line. There is the function sort. It's sorting up from sorting down or up. The transpose of the function, I think you know what is here. If I write CLC, sorry, so I can see x equal, this is the column wise. If I click and x and write the quotation, one quotation, it give me the transpose function of the or the transpose version of the this vector or this array. There is something else I didn't write. This is all of them array. So for example, if I want to generate something 2 columns or 3 columns, 1 2 3, as I said, the space is differentiating between 2 columns, but the semicolon is differentiating between 4 5 6. Semicolon differentiating between 2 columns, so 7 8 9. Enter. Then I have a matrix that's 3 column and 3 row. If I continue 10 to 11, if I click enter, why? Because the dimension is not good here, because I put 2 numbers 12. Now here it's okay, so it's how many row, how many column I can use size. Why? It gives me number of row 1 2 3 4, number of row, and number of columns 3. The length, the other side. If you write the function itself without the input, it gives me an error. Why? Where is not enough input argument, so I should write the input. Yes, so it gives me the length, the higher length of the column, of the number of rows, the higher length of this function. Okay, you can go to the documentation to see more details. So we go to for these values, maximum find location. We take this also. This is I function. I don't know if you know I function. I function gives you the diagonal with this value 1 1 1, the diagonal value, and everything is 0, which is very useful in mathematics, algebra, I think. That true, it gives me the 1 by 1 everything, false 0 0 0 0 everything. This is you can learn it by yourself. I just pick up the value that is important for us. Here it gives how I can sum or apply the operation, the arithmetic operators on the mathematical version of the vector. And yeah, if you see here, this is important. C equal to, I put two spaces, or two field of matrices. I put both of them here inside one, a large one, to implement a large one. I can put a small dimension of a different one from 1 to 5, for example, of 1 to 4, and I can enlarge the dimension. So MATLAB gives you a variety of options that is easy to work with. So I can just put like this, and it will understand that I want to put all of the elements of the first one, the A, from 1 to 5, and then I put the elements of P from 1 to 9. This is after each other, to implement a new one that is twice the dimension of the first and second one, or maybe the summation of the dimension of both of them. It doesn't matter, but the main important thing is you don't have to make some error in the dimension if there is a 2-dimension or 3-dimension matrix. Okay. Another thing is that the arithmetic operator. If I have an A, I don't no, we don't have A, we have X and we have Y. Yeah. Now, if I want to apply something on the arithmetic operators on matrices, so I have X here. If I multiply 2 by X minus 4, what is the output? I will get to output in Z. Okay. Now, I get the output like this. So the arithmetic operators of writing, multiplying, dividing, summation, subtraction of a constant, it is easy. It's like you work with a variable. You work with the vectors or array, the same concept, but you just pay attention for the mathematics of the matrices when you multiply or substitute or something, make something to two matrices, not just one. So when I write, for example, y equal to, no, not y, q, doesn't matter what is the name. So q equal to the, for example, x plus y. If you remember y here, y is dimension like this and x is dimension like this. Oh, so you have a problem. Matrix dimension must agree. Why? Because which element I should add to which element. I have different dimension here. The first one is okay, second, third, but where is the corresponding element to the other one? So I should apply, for example, here q, but here I have the same dimension z and x. Yes, so if I remove, I put, yeah, so it's just summation x and z and give me the output. So x and z, because both of them are the same dimension. However, this is okay for summation and subtraction. For the multiplication, I don't know if you know, from the multiplication division is the inverse of the multiplication, so we don't know go there. But the multiplication of a matrix by another matrix the multiplication of a matrix by another matrix is you multiply each row from the first matrix and with the each column from the second matrix. So if I want, for example, R equal to x multiplied by z, yeah, both of them the same dimension, but if I click enter, give me error because the dimension for matrix multiplication is not the same. However, if I make something like this, it gives me a number, one number. Why? Because I will write just an explanation. It's not the thing that it's not an expression. The first x is one row multiplied by one row and 10, yes, yeah, 10 columns, yes, and the second one is one row and 10 columns, but I have to make agreement. So the number of columns for the first one supposed to be the same, equal to the number of row for the second one. So I take the transpose make the column row and the row column, so it give me something like this, the transpose like this. So here I have the value, this value it's the same, the number of columns for the first one the same, equal to the number of row for the second matrix. Okay, so it's now it is okay for multiplication. Okay, so what is the output? This both of them, you should, if you remember, you should multiply the first element of the first row by the first element of the first column, and then summation the second, third, fourth, all of them, and summation. Then this is just the first value, or the first place in the output, uh, in the output matrix. But here we have only one and one. I have an explicit way of seeing what is the output, what is the dimension of my output. If you remove this, if you remove this, the both of them in the inside, this is the corresponding dimension. Then this is a dimension of the output. The dimension of the output is 1 by 1. Whatever the value, it will give you like this. So the dimension of the output is the same. So for example, if we have here, what we have, y. Yeah, y. If we have the same dimension like this, and we remove from here y, and we make it a w, for example. Now we have another one that is the same. If I multiply w by y, it gives me a error. But if I multiply w by y, yeah, so here it gives me 4 by 4. Why? Because the first one is 3 by 4, second one is 4 by 3, and 3 by 4. So the 3 and 3, it is removed, and then I have 4 by 4 matrix. Okay, but there is another thing of matrices multiplication called the matrix element by element wise multiplication. Here he said this is to multiply, to make a perform of an element wise multiplication, use a dot here. See this one? So this one is just multiplying, the same idea, w e equal to w multiplied by y. This is give me error. Why? Because this is the normal multiplication or matrix multiplication. But if I want to just multiply the first element in my first in w by the first element in y, the second element in the second element multiplication, which is different, so I just put dot before the multiplication operator. It will give me another one that's the same dimension as w and y, but it just multiply each element by the corresponding element in the second matrix. Okay, the same idea in the other operators. So and you can just here's the same, and also you can take it to the power something, or take the element to the power something. So the same operator that you apply to the vector, to the variable, you can apply to the matrices, but you have to take care. Yeah, the flooring or approximation function. The approximation function means that you should approximate something. I have a value here of 3.4. What I want to approximate it. Why? Or why? Because usually we want to work with integer number, for example. I don't want to work with floating number. How I can approximate it? I approximate it using some function, this one and this one. Yeah, floor. I just write the number inside the function and give me something, but there is 4 of them. The floor, it round the value toward the negative infinity, toward the downside. Whatever the value, it 0.4, 0.5, 0.8, it will floor. seal it toward up, so 3.9 it will give me 4. This is how it's going on. Fixed, it will give me towards 0. If I have 3.4 it will be 3, but if I have minus 4.4 it will give me 4. So it go up to the toward 0. Okay, normal approximation, it round whatever under 0 0.5 to the lower, and if it is above 0 0.5 it is go up. So round, it is a normal approximation that we usually use, but we have different type of approximation if you want it for different type of application. Okay, this is binary to decimal and decimal to binary. You can use it wherever. This is the character and how to work with characters. Yeah, I think this is, I will lift it to next lecture. Thank you.